So, hello everyone, I'm Asta, and in this video I'll walk you through my project on multimodal sentiment analysis. So, uh, in real life, humans do not rely on one thing. We read expression, we read tone of voice, and what is being said, right? So that is exactly what this model is trying to mimic by learning from both the text and images together. So one may say that why multimodal sentiment analysis is even useful. So it is useful in the field of social media moderation, fake news detection, or just genre classification, movie genre classification, and yeah. So let's get further into it. So uh, now in this, I have used synthetic data. Okay, so why synthetic data? Okay, uh, because real world multimodal data sets are very hard to find, and even they are very harder to process. So I have used synthetic data, which simply means auto generated text and images, to quickly prototype and test my data. Now, the goal is to predict that if the sentiment expressed in both the images and text is positive or negative. There's one more reason I used synthetic data, because I tried to use the real life data, but it was this much large that my machine couldn't process it. That's why I shifted to synthetic data. So in the synthetic data creation, two. Uh, I have utilized two main things. One is the BERT tokenizer, which convert my textual data into numerical representation, and another is ResNet, which I have used for my image data. So it is used for building pipelines, and uh, then I just predict my model just predict if the sentiment expressed in both the images and the text was is positive or negative. So let's go to my multimodal model. So in now let's talk about BERT, which I have used for my textual text. So BERT stand for bidirectional encoder representation from transformer. So traditionally, what happens? Model read from text left to right, but BERT reads in both directions. So that allows it to understand concept better. So for example, if you're saying he went to bank to deposit money, uh, BRT can tell that bank refer to financial institution, because it reads the whole sentence at once, not from text left to right, right? So it is already pre-trained on very large text corpus. That's why it can be fine-tuned for sentimental analysis. Now my model has mainly two branches. One is your text and one is for image. So text side, I have used BRT to tokenize and convert the input sentences into embeddings, and I have extracted CLS token, which act as a summary of a sentence. Now on the image side, I have used ResNet 18, which is a classic convolutional neural network, which is trained for image recognition. So what happens in ResNet, you train the residual network, making it more firm, making it more much better. Okay, then what I do, after extracting image from both feature and after extracting feature from both text and images, I concatenate them so as to create a final feature vector which has features from both images and text, and that I pass in my final classifier, and that predicts a binary prediction, 0 for negative and 1 for positive sentiment. So we have reached the conclusion part, but I want to walk you through through my code. So I have created a PyTorch dataset. So you can see it, PyTorch dataset class, for generating text like this is a sample text 5, a random RGB file. So each sample is labeled 0 and 1 to simulate real sentiment labels. Then in the training loop, the the data is fed into the batches to the model and calculate loss, and then you update the weight. For evaluation, I have used measure and loss accuracy on a separate validation test. So this project, if I'm talking about this project in general, it has helped me learn that why the multimodal multimodal models are this important, and why do we create I mean, it has also helped me learn that how to build a multimodal neural network using transfer learning. Now, the next step for this project would be to replace the synthetic dataset with a real dataset such as CMU MOSI, which include text, image, and audio file. Thank you for watching.